Okay, so this is the second video of the project that I did make, which is a custom object detector. Unfortunately, there hasn't been enough basketball data that has been made available online, especially for free. So I had to make my own custom object detector, which I had to do with TensorFlow. And I did mention that TensorFlow is faster than uh, YOLO because it has a TensorFlow Lite, which TensorFlow Lite version, which is supported on the Raspberry Pi, and it loads about 5 million times faster than a normal object detector model. This is just me putting bounding boxes on the objects that I would wish to track in my model. So here, that's a human being, basketball, human being, and a hoop. So I had to do this for 1,000 images because I noticed that every time that I did put less images, uh, the the object detector was not working too well. So these are some of the images that I did put labels on. So there are quite a lot of them. But one of the things that I have to bring to your attention is occlusion. So as you can see here, the hand is covering the basketball. So sometimes I'd have to put a bounding box on just this part of the basketball going up to here to the end and leave out the human hand because sometimes the object detector would get confused between a human hand and a basketball. So uh, that was that. This was the training. So I did training on Google Colab because my computer was not fast enough to be able to train the model. But even though training one model would take me at least 3 days, this is because there were a lot of pictures to process. Uh, there were a lot of pictures, so I did 13 models in total. And these are the results of the final model. As you can see, it is tracking everything quite well, even the human face in that direction. But it did have some errors, some mistakes that it'll make. Like right here, as you can see, it says that the basketball is 99% probability, but when it comes here, it also says a hoop is 95%, which is quite wrong. So yeah, those are some of the mistakes. On this picture, it fails to track the athlete, which should be a bounding box right here, but it does track the basketball and the hoop quite well. So that is good. This one is quite good. The other thing that I need to bring to attention, the reason why I had to develop trackers for the basketball and the human being. As you can see, this is the second model that I made. This one could not even track the ball as compared to this one. But even with this one, it was failing to keep up with the ball consistently. It would track from time to time, and it would even work because this ball was not moving that fast. But if you can see from the video is quite slow too. So it's not even moving that fast. So um, that's pretty much it. So what I had to do was to make another model for this. But even with this one that was working, it also had some errors. As you can see, when the person turns around, which I'm just going to show right now, it loses track of the ball. That is because the ball has changed dimensions and certain parts of the ball cannot be seen. And tracking is all about keeping up with an object. So since this ball is moving quite fast in relative to the program, it's not even moving fast. The on the video, the human was not moving quite fast, but the TensorFlow model on the computer is a bit slow, so it does lose track of to. So here what happened was, since the model was quite slow, what I had to do was to do this on a camera. So I'll point the phone camera to the screen, which would then be detected by the object detector because it works faster when it is not processing frames from an object within the system, which was quite good because the Raspberry Pi was gonna use live feed, which it did. So yeah, this was pretty much it from the object detector, and I mainly used it at the end to just track the hoop because I noticed that it wasn't doing justice for the human being and the ball. Uh, Also, what I did, since the Raspberry Pi could not run all the programs at once, I would make the object, I'd call a program that would make the object detector run and store the coordinates of this hoop. If it's above a probability of 70%, it'll write those coordinates to an Excel file. Then the next program that comes that is opened after the object detector closes would just use those coordinates and use it to do shot detection or anything else that needs to be done. So that's it for the